Now we will look at window ratings, and there's a fair bit of specialized vocabulary, special words that go with windows, beginning with the word glazing. When architects and builders talk about glazing, what they mean is windows. Architects and builders also use the word fenestration, and oftentimes, at least some of us, when we say fenestration, we're really thinking about windows, but to be precise, it's any kind of opening in the wall of a building. So the National Fenestration Rating Council is a council that applies standards to all the windows that you buy. And if you buy a window from a supplier, you will always see one of these labels on the window that gives numbers about various kinds of ratings, how it meets various standards. And the National Fenestration Rating Council standards are included by reference in various codes and standards, including the Energy Code and ASHRAE 90.1, which is the Building Energy Standard, LEED, and the Energy Star from the U.S. government. The first number we'll look at is called the U value, and you are probably, well, you might be familiar with that one already. You're really probably familiar with R value. When we talk about insulation in a wall, we think about R value. So in a wall, we want a big R value. That means it's good at insulating. Well, the flip side of that is you want a small U value. So R value is good, small U value is good. And the reason for that is just the U value is nothing more than a fraction, 1 divided by the R value. So for example, if you had a wall where the R value were 20, R20, that means the U value would be 1 over 20. Or if you punch that in your calculator, you find out that's 0.05. If the wall's R value were, 50, R50, the U value would be 1 over 50, so an even smaller number. U value means how much does the window conduct heat or not conduct heat, and so that's why you want a low U value. You don't want heat leaking out through that window. You want a low U value. And on these fenestration labels, you will always see a number for the U value. Another number you will see is the solar heat gain coefficient. And this is when the sun shines on a window, how much of that heat from the sun gets in and how much gets blocked. And you might pick a different kind of window depending on what you're trying to do and where the window is in your house. If the window is on the south side of your house and you're trying to do some passive solar heating, you would want a higher solar heat gain coefficient because you would want the window to let solar heat in. Then, of course, you want window glass that lets light in and without distortion. So VT, visible transmittance, is a measure of how much does it let the visible portion of the light spectrum come in through the window. Then you want to know, what is the infiltration rate of this window? Is this window allowing air and heat to leak through or not? So you get a measure of the infiltration rate, the air leakage, on the label. And I call your attention to CFM, cubic feet per minute. If you were a technician in heating and air conditioning, you would be concerned with CFM in several ways. One way you'd want to know how many CFM of airflow do you have from your heating or cooling unit, so you'd talk about CFM. But before that, you'd be doing a heat load calculation or a cooling load calculation, and you'd go around and you'd tally up what's the R value, what's the U value, what's the infiltration rate of all these surfaces on your envelope. And so you can use this air leakage number as part of your heat load calculation or your cooling load calculation. You probably won't have to do that. You'll probably have an HVAC technician do that, but it's interesting to know about. Some windows have a number here that talks about its ability, the window's ability to resist condensation, which in some climates especially you would care about. And finally, last 3 slides here, there's a kind of glass called low E glass, which stands for low emissivity. Think of the word emission. It emits something. And low E glass has a thin coating of metal on one side of the glass. I don't know precisely what kind of metal coating it is, but it's invisible, which is interesting, and it has full visible transmittance. It lets light in. So, but it blocks infrared radiation, so either keeps heat from building up or keeps heat from escaping. And here in this black and white diagram, on the left is a diagram of a plain glass window. So sunlight comes in from outside and gets through the glass. Most of it gets through. And then inside you have radiant terrestrial radiation given off by you and your computer and your furniture and everything. Some of that radiation gets back out through the glass, and some of it bounces back. If you have low E glass, if you put it with the low E coating on the outside of the window, facing outward, that coating reflects the solar radiation and keeps your room from overheating. So you can see here it bounces the solar infrared radiation back out into the outdoors. So this might be an issue if you were worried about overheating, especially if you had windows on the south side, you were not doing passive solar heating, and you were worried about keeping it cool inside. You'd put low E coating toward the outside of your window. Here on the left picture, if you put the low E coating on the inside of the window towards the room, then what it does is it blocks the emission of that terrestrial radiation from inside your room, and it keeps the heat inside. If you were building a house in a cold climate and you wanted to keep the heat in, you would use low E glass with the coating on the inside. And finally, you can get this thing called spectrally selective low E. So I don't quite know how it works, but it blocks some radiation and lets others in.